5.2, Sum and Difference Formulas. There are formulas to find the sine of A plus B. So the sine of A plus B, where A and B are angles, is not just the sine of A plus the sine of B added together, as you see down here. It's a very big mistake. Don't do that. So there are formulas for when two angles are added together. So the sine of A plus B equals the sine of A times the cosine of B plus the sine of B times the cosine of A. You don't have to memorize this. It'll always be at your disposal to look at, but you do have to know when to use it. The formula for the sine of A minus B is the same as sine of A plus B, except for that there's a minus in the middle instead of a plus, and that is the only difference. Okay, now for the cosine. Cosine of A plus B equals cosine of A times cosine of B minus sine of A times sine of B. Now I want you to notice that with cosine, when there's a plus in between the A and B, in the formula there's a minus, so the sign switches. Again, you don't have to memorize this, but if you're looking quickly, then you could accidentally write it incorrectly. And likewise, when you have cosine A minus B, the formula is the same, cosine A times cosine B, but the sign switches. So now, when it's cosine A minus B, you need to use a plus in the formula. But as you see, the rest of the formula is the same. And this is the big takeaway. The sine of two angles together does not equal the sine of the angle plus the sine of the other angle. It's just not true. So this is really, really important. You're going to do it anyway, I know it, but hopefully maybe I'll catch somebody. Okay, so let's use this in an example. Find the cosine of 15 degrees. Now, I don't know what the cosine of 15 degrees is, and you probably don't either. But what we're going to do is we're going to use one of these formulas to help us get the cosine of 15. So I have some steps written down here, A, B, C, and D. So the first thing you want to do is find two special angles that will add or subtract to get 15. So think about what numbers you could use that would add or subtract to get 15, but you only want to use special angles. So what are our special angles? 0, 30, 45, 60, 90, 135, oh, I forgot 120, 150, and so on. So, and it doesn't matter which pair you use as long as they add or subtract to get 15. So the ones that stand out to me are 60 and 45. So 60 minus 45 equals 15. And I know what the sine and cosine of 60 are and the sine and cosine of 45 are. So I'm going to be able to use this. So we're going to rewrite the cosine of 15 as the cosine of 60 minus 45. And that's so that it's written in the same form as the original formula here. Oh, wow, that got a little crazy, didn't it? Okay. So let's decide who's A and who's B. Well, it's not that hard, thank goodness. So A is just the first number, and B is just the second number. And then we're going to put A and B into the appropriate formula. So I put a box around the appropriate formula in pink. So that's the formula that we're going to use. So I'm just going to copy that and drag it down here. Well, now that didn't work, did it? Okay, well, forget that. That was fun. I forgot it won't copy words. Oh, yes, it will. I just forgot how. I know what to do. Copy. Ha, now I got it. Okay. Now I got a little extra stuff here, but that's okay. So instead of A, we're going to put 60 there. And instead of B, we're going to put 45 there. Doo-doo-doo. And now for these A's, I'm going to take the A's out. And what am I going to put in its place? I'm going to put 60 because A is 60. So I'm going to put a 60 here, and I'm going to put a 60 here. Choose a different color. Okay. Now we're going to replace those B's with our B number, which was 45. Doo-doo-doo. Now these are values that we know, so we can actually find the trig values of these. That was bothering me. Okay, so let's see here. The cosine of 60 is 1/2. And the cosine of 45 is radical 2/2. The sine of 60 is radical 3/2. And the sine of 45 is radical 2/2. Now I have all the values I need in there to answer this question. Remember to use order of operations. So this will be radical 2/4 plus radical 6/4. And then add those together. Oops. Remember, you can't actually add underneath radical signs, so you just leave them alone. But we can keep the denominator as a 4. And there we go. So the cosine of 15, let's write that in here, is radical 2 plus radical 6 all over radical 4. So you need to apply this formula when you have an angle that you don't know the cosine or sine of, but that you can get from using other angles. Let's look at this one. This one looks totally different. I don't know the cosine of 80 or the cosine of 20, do you? But if you notice, this looks like somebody already took the numbers and put them into the formula. Doesn't it look like that? Look at this. Doesn't this look like that? But what's A? Look at what A is. It's 80. And what's B? That's right, it's 20. So we're just going to use this formula, but we're going to use it backwards. So cosine of A minus B equals cosine A times cosine B plus sine A times sine B. Now you might not think there's anything we can do with this, but just wait. So if we compare this to what they gave us, oh boy. There we go. This is cosine 80, cosine 20, sine 80, sine 20. So if we work backwards, you can see that this will equal the cosine of 80 minus 20. What is 80 minus 20? It's 60. And the cosine of 60, that's a number we know. It's 1/2. That's a weird way to use that formula, isn't it? It looks like it's going to be so bad, but it's really not. Ooh, now we have a verifying, just like in the last section. So we have to make cosine A minus B over sine A times cosine B look like cotangent A plus tangent B. Well, let's see if we can make this happen. Let's start with cosine of A minus B. Let's change him into the formula that we just learned. So cosine of A minus B equals cosine A times cosine B plus, remember the cosine changes signs, sine A times sine B. And all of that is over sine A times cosine B. That part wasn't changed. Okay, now let's see here. I have two terms on the top. I have a fraction and these multiplied things on the bottom. And over here, I just have two terms. So I'm thinking that I should try to split this up into two fractions. So I'm going to take this denominator and divide the first term by it, and then divide the second term by it, and have two separate fractions. So that's cosine A times cosine B over sine A times cosine B plus sine A sine B, that's this one, over sine A cosine B. You can probably see that stuff is going to cancel here. So the cosine B's cancel and these sines cancel. That's got to be helpful. Now I have cosine A over sine A plus sine B over cosine B. So cosine A over sine A, let's think back to our identities. What does cosine over sine equal? That equals cotangent. And the important part here is to realize that these are the same angle. And that's why I'm allowed to do this. If this was a cosine A and sine of something else like B, then I would not be able to do this. Sine B over cosine B here, that's tangent B. And I believe that that is what we were trying to get in the first place. Let's see. Yes. They match. So we use the formula in three different ways now. We use the formula to find the cosine of an angle that we previously did not know what the cosine of it was. We use the formula in reverse. And then we use this formula to verify an identity. Okay. Now you're going to try this one on your own. So what I want you to do now is stop the video. And then I want you to try to verify this trig identity. And then when you're done, I want you to turn the video back on and see if you were successful. I wonder how many of you will actually follow those steps. Go ahead, pause the video. All right, I hope you actually paused the video. I could just stop here and wait, but that seems ridiculous. You could just pause the video. Okay, so we're going to take our cosine A minus B, and we're going to use our new formula with that. Cosine A, cosine B, change the sign. Sine A, sine B. I'm going to leave the bottom the same because I don't have formulas for those. And similar to the last one, I have multiple terms in the numerator here. I have two terms here. This is actually two terms, even though, I'm sorry, this is actually one term, excuse me, even though it looks like two terms, because you don't get another term until you hit another plus or minus sign. So let's attack this the same way. So we'll split this up into two fractions. So that's cosine A cosine B over cosine A cosine B. I'll bet you can see what's going to happen there. Plus sine A sine B over cosine A cosine B. So this is going to cancel, and these are going to cancel. But remember, when stuff cancels by division, you really get a 1, okay? You don't get like a nothing, so be careful with that. Sine A over cosine A is tangent A. And sine B over cosine B is tangent B. And we're done. And they match, right? Okay. All right, let's have some practice with radians instead of degrees. But this is just going to be like the first example. Find the sine of pi over 12. So the first thing we need to do is find two special angles that will add or subtract to get 12. Okay, you might not recognize them as special angles in the beginning, so I would just start with twelfths. What are some twelfths that you can subtract that will get 1/12? Well, you could have 2 minus 1. You could have 3 minus 2. You could have 4 minus 3. Or 6 minus 5. We could keep doing this for a while. But you want to make sure that the angles you pick will simplify to something that is a special angle. So my thought was to choose 4 pi over 12 minus 3 pi over 12, which of course is equal to 1 pi over 12. But this is a good choice because 4 pi over 12 is pi over 3. And 3 pi over 12 is pi over 4. And these are both special angles, so I will be able to find the trig values of those. But let's say you didn't pick this. Let's say you picked instead maybe 3 pi over 12 minus 2 pi over 12. That still gives us 1 pi over 12. But do these simplify to get special angles? Well, this one is pi over 4, so that's fine. And this one is pi over 6, and that's also fine. So this would work just as well. What you want to be careful of is choosing something that's not going to work. For instance, 5 pi over 12 minus 4 pi over 12. 4 pi over 12 is fine because it's pi over 3. But 5 pi over 12 can't be simplified, and I don't know how big 5 pi over 12 is. Well, I know how big it is, but I don't know the sine or cosine of it, so this combination would not help me. But there are different numbers you could pick as long as they're going to add or subtract to get 1 pi over 12, and as long as they're going to become angles that you know the trig values of. So we're going to rewrite our sine pi over 12 as sine of pi over 3 minus pi over 4. And let's determine who A and B are going to be. But that's easy because A is just going to be the first one and B is going to be the second one. But then you also have to determine which formula is appropriate. So you have sine and you have a minus. So this is going to be the formula sine of A minus B. And that, if you want to look back up at the top, equals sine of A cosine of B, keep the same sign, sine of B cosine of A. Okay, so now I can put in my my radians. Come over here. Sine pi over 3 times cosine pi over 4 minus sine pi over 4 times cosine pi over 3. Let's see what we get from this. So the sine of pi over 3 is radical 3 over 2. Cosine of pi over 4 is radical 2 over 2. That was an awfully long minus sign. Sine of pi over 4 is radical 2 over 2, and cosine of pi over 3 is 1/2. That's radical 6 over 4 minus radical 2 over 4, which equals radical 6 minus radical 2 over 4. And you might notice that this looks pretty similar to the one we did that was 15, the cosine of 15. But that's because these have the same reference angle. In fact, 15 degrees is pi over 12. So it's not surprising that I got quite similar answers. Let's try another one. Find sine of 5 pi over 12. So again, you're going to think about two special angles that will add or subtract to get 5 pi over 12. But you don't have to worry about the thirds and the fourths and the sixths just yet. You can just work with twelfths, and then you can simplify them to see if it's going to work. So 5 pi over 12, let's see. I could do addition with 3 pi over 12 plus 2 pi over 12. I could do subtraction with 8 pi over 12 minus 3 pi over 12. Or, what else? I could do 9 pi over 12 minus 4 pi over 12. Any of these combinations would work. It's probably easier if you choose angles that are in the first quadrant, because then you won't have to worry about the signs, being negative. But really, any of these would work. We'll just stick with the simple one for now. So 3/12 plus 2/12. Oh boy, that was interesting. 3/12 plus 2/12 equals 5/12. So that's what we're going to pick for that one. Okay. So we're going to rewrite this as sine of 3 pi over 12 plus 2 pi over 12. Okay, we're not really going to do that. We're going to simplify these. I forgot. So 3 pi over 12 is pi over 4, and 2 pi over 12 is pi over 6. So those are actually the numbers I want to use in there, but that's okay. I'll just write them here. And that's good because pi over 4 and pi over 6 are special angles. So A will be pi over 4, and B will be pi over 6. And then we'll have to write the appropriate formula. So this is a sine of two angles added together. So this is going to be sine of A plus B. And our formula for that is sine A, cosine B, keep the sine, sine B, cosine A. And now we'll go ahead and fill everybody in here. So sine of A was pi over 4, and cosine of B was pi over 6, plus sine of B, cosine of A. Sine of pi over 4 is radical 2 over 2. Cosine of pi over 6 is radical 3 over 2. Sine of pi over 6 is 1/2. Cosine of pi over 4 is root 2 over 2. So that's going to be radical 6 over 4 plus radical 2 over 2, which equals radical 6 plus radical 2. Oops, I made a mistake. I'm sorry, that's a 4. All over 4. Again, it looks a lot like the other answers, but these are all twelfths or 15 degrees. So it does make sense because reference angles tend to have the same looking, sine and cosine. Now this is a totally different kind of example. Sine of A equals 12 over 13, and angle A is in quadrant 2. Sine of B equals 3 over 5, and angle B is in quadrant 1. And then we have to find the cosine of A plus B and the sine of A plus B. These are not numbers I am aware of. I'm going to have to draw a triangle. Now I'm going to draw this triangle as if it's oriented in quadrant 2. So that's why I have it pointing this way. So this is angle A, and the sine of angle A is 12 over 13, so opposite over hypotenuse. And that's going to make the adjacent side 5, but it is going to the left, so this is going to be -5. Or you can think about that it's in quadrant 2. But if you were to imagine an XY axis here, -5 is to the left. Well, that's in my way now. Oh, that's going to bother me. Ah, got it. Okay. So now let's come over here and look at angle B. Angle B, the sine of angle B is 3/5, and B is in quadrant 1. So I'm going to draw an angle like it's in quadrant 1. And the sine of it, of B, is 3/5. So opposite over hypotenuse. And that's going to make the adjacent side 4. So now from this, I could list the sine of A. That was actually given, though. That's 12 over 13. And I could list the cosine of A, which is -5 over 13. And then for angle B, the sine of angle B is 3 over 5. And the cosine of angle B is 4 over 5. And the reason I want to do that is because I have to find the cosine of A plus B. And the cosine of A plus B involves the sine and cosine of A and B. Because that formula is cosine of A plus B equals cosine A times cosine B minus sine A sine B. So this is 4 separate values I need to have here, but I have them all listed above. So that's going to help me, not lose anybody. So cosine of A is -5 over 13. Cosine of B is 4/5. Sine of A, 12 over 13. And sine of B, 3/5. You never had to know what A and B were. So you got to let that go. Don't pick up your calculator. Don't do inverse cosine. Nobody actually cares what A and B are. You just have to worry about what the cosine of A plus B is. So we're multiplying fractions here. I would recommend not cross-canceling because you're going to wind up needing a common denominator in a minute anyway. So that's going to be -20 over 65, because that's 13 times 5, minus 12 times 3, which is 36, over 65. See, so if you had cross-canceled here and gotten rid of these 5s, you would have had to have multiplied it by 5 in a second anyway to get a common denominator. So, and that happens most of the time, so don't cross-cancel. So we have -20 minus 36 is -56. Keep the denominator. And there we have it. And you never had to find A or B. Keep that in mind. Okay, let's try another example. It's very similar. Sine of A is 4/5, and angle A is in quadrant 2. Sine of B is 1/2, and angle B is in quadrant 1. Oh, that was supposed to be a small b. So we're going to draw 2 triangles. We're going to draw one triangle in quadrant 2, and we're going to draw the other one in quadrant 1. So here's A, because remember, A really comes from the positive x-axis. So even though we're going to look at this angle, A is really this angle on the outside. So sine of angle A is 4/5. Sine of B is 1/2. And now we're going to have to find the other sides. So the adjacent side on the triangle with angle A is 3. And the adjacent side on this triangle, that's going to be, we'll call that x. So 1 squared plus x squared equals 2 squared, the Pythagorean theorem. We're going to get 1 plus x squared equals 4. So x squared equals 3. So x equals the square root of 3. If you can do that in your head, more power to you. So let's just make a list of all the sines and cosines, because we're going to need them for either the sine or the cosine formula. So I like to just write them all together so that I'm organized and I don't need to go looking for people. So sine of A is 4/5, that was given. And the cosine of A is, oh, I forgot, it's negative 3/5. Because, I didn't write that right, shoot. I'm sorry, that's supposed to be an A. Because A is in the second quadrant, and the cosine in the second quadrant is negative. So it does make sense that that's negative. Sine of B is 1/2, that was given. Cosine of B is radical 3 over 2. So now I'm all ready to use my cosine A minus B formula. So cosine A minus B equals cosine A cosine B plus sine A sine B. Cosine of A is negative 3/5. Cosine of B is radical 3 over 2. Plus sine of A is 4/5. And sine of B is 1/2. So negative 3 radical 3 over 10 plus 4 over 10. Which equals 4 minus 3 radical 3 all over 10. Okay. Let's try the sine of A minus B. I feel like I skipped one from above, didn't I? I did. Whoops. Well, I'll tell you what. Let's leave these to you. So you go ahead and do sine of A plus B by yourself. And on this one, you go ahead and do sine of A minus B by yourself. The good news is, really, most of the work is done because the triangles are already drawn and the values, we already have them all listed here. You just need to put them into the formula. So I'll write down what these answers are so that you can match up your answers, but I would really like you to try this on your own. So see if you can get 33 over 65 for that one. And for this one, let's see if you can get 4 radical 3 plus 3 over 10. But you try those on your own. Okay, finally we have the tangent formula. So we have the cosine sum and difference formula, the sine sum and difference formula, and now for the tangent sum and difference formula. But remember, you don't have to memorize these. Okay, so tangent actually starts out kind of easy. So tangent of A plus B equals tangent of A plus tangent of B. That's convenient, but there's this whole fraction involved. So tangent of A plus B equals tangent of A plus tangent of B over 1 minus tangent A times tangent B. So some things I want you to notice. This plus matches this plus, but the bottom sign is opposite. Okay, similarly, for A tangent A minus B, I still get on the top tangent A and tangent B, but now the sign in between is a minus, which matches this one. On the bottom, I still get the 1 and the tangent A and the tangent B, but the bottom sign is opposite the one on the top. Okay, let's use these new formulas to verify that tangent x minus pi over 4 equals tangent x minus 1 over tangent x plus 1. So verifying with these can be a little daunting at first, but they're really not that bad. In fact, I think they're a little easier because you kind of know right off the bat which formula you should use. So we're going to use this new tangent formula. So tangent of x minus pi over 4 equals tangent x minus tangent pi over 4 over 1 plus, switch the sign, tangent x times tangent pi over 4. Ah, but what is tangent pi over 4? It's 1. The tangent of pi over 4 is 1. So I can rewrite this as tangent x minus 1 over 1 plus tangent x times 1. Doesn't that equal what we wanted to anyway? Tan x minus 1, just a little rearranging, equals tangent x plus 1. That wasn't so bad, was it? Okay, one more, and then we'll be done. Verify that tangent of x plus pi equals tangent x. So again, we'll apply our sum of tangent formula, right? That equals tangent x plus tangent pi over 1 minus, remember to switch the sign, tangent x times tangent pi. Well, what's the tangent of pi? It's 0. So now the top is tangent x, and the bottom is 1 minus tangent x times 0. But of course, anything times 0 is 0. And so then this becomes tangent x over just 1, but I don't need to write the over 1. And I'm done again. Oops. And that's it. I hope you've so enjoyed today's video, and I hope that you can do your homework now. If you can't, though, that's okay. Just upload your notes, and you can wait until we go over some problems in class tomorrow. And then if you want to do your homework after that and submit it later tomorrow, that's okay too. I changed the due times until like midnight, so you have all day to do it.